Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 सीबीसीएस ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें ऑप्टिकल स्विचिंग एंड ऑप्टिकल डाटा स्टोरेज विषय रे पढिबा So we know that the nanomaterials have wide range of application, and in recent years the semiconducting nanomaterials are intensively used for the purpose of both academic and industrial research. Now there are basically two major properties of these nanomaterials. Number one, electronic, and number two, optical. Okay, so these electronic and optical properties can be used for the construction of advanced optoelectronic nano devices, right? Now the fabrication of nanostructured materials with controlled structures and novel properties is very important for such applications, right? The optoelectronic response and surface chemical properties of these nanomaterials were found to be very promising for the successful demonstration of these optical switches and detectors. Okay, basically what we mean by saying these optical switches means, suppose light which is falling on a material and you design the material in such a way that it will be turned on at a particular wavelength when the light is crossing a particular wavelength or frequency, or it will be turned off, so it is acting like a switch. So this is called your optical switch. Okay, and also detector, that means it can detect whether the light is harmful like your UV or infrared. Okay, so presently most of the communication and networking equipments are based on the electrical signals, and hence the optical signals must be converted into the electrical signals and amplified. Okay, and it will be regenerated or switched, right? Then the electrical signals are reconverted to optical signals for the transmission purpose, and this process is commonly known as OEO, that is optical to electrical optical conversion. Okay, hence the basic requirement for the optical switching is to replace the existing electronic network switches by optical switches in order to eliminate the need for this OEO conversion. And there are many advantages of avoiding this OEO conversion, which are: number one, to overcome the complexity in case of OEO conversion. Then secondly, optical switching is comparatively cheaper, and thirdly, physically smaller switches can also be fabricated. Now recently these optical switches are considered as the key features in the fiber optic communications network, and these optical switching has become an important component in case of telecommunication sector. And currently the optical switches are being used in the optical circuits in order to select a particular wavelength, as I was telling, and restore the optical paths in case of link failure and for signal monitoring purpose, right? So most of these optical switches are referred as optoelectronic devices. Why so? Because they convert the optical input signal into the electronic signal for switching purpose. Thereafter the electronic signals are used to drive the optical transmitter. So some of the optical switches can separate a particular wavelength readily, means very easily. Okay, so these optical switches can evaluate the signals in the form of light radiation, which could be either in form of your find wavelength or multiple wavelengths. Okay, and there are a number of techniques
for fabrication of optical switches, and some of the techniques are here briefly explained. Number one is the optomechanical switches. So the optical switching was commercially visualized through this optomechanical technology, and here the switching functions are done by mechanical means with the help of certain optical instruments like that of your prisms, mirrors and directional couplers. Also the electromechanical actuators can be used in these switches to redirect the light beam. Okay, secondly, the electro-optic switches. Here if an electric field is being applied, then this device starts to vary non-isotropically as a function of the refractive index of the target in the device. So the variation in the refractive index will guide the light through the appropriate path to the desired port. Okay, and the switching functions are extremely fast in this case and reliable, okay, in the electro optic switches. But the demerit is that the insertion loss will ruin the overall efficiency in the electro optic switches. Okay, the third one is the thermo optic switches. So from the name it suggests that here heat energy is being utilized. So these devices are based on the thermo optic effect, and the temperature variation in the material will cause the variation in its refractive index. Okay, and this helps in guiding the light. And in these devices the driving voltage will perform the switching actions. Okay, now next one is the electro holographic switches, where the switching functions are controlled by means of the electric field and hologram, and these switches are based on the beam deflection method. Then your bubble switches, where these devices are made up of two layers of silicon, and out of which one will serve as the optical signal transmitter and the other one is linked with the inkjet technology. And lastly, the liquid crystal switches, where these devices are based on the polarization of light, and if a desired voltage is applied across the crystal layer, then light is being switched between the two states. Okay, as we know, liquid crystal means it is showing polarity. Okay, so basically when you apply electric or magnetic field to a liquid crystal, then its molecules will be polarized, right? So the light will pass through one state but does not pass through the other state. Okay, so it will be switched between the two states, right? So this is your optical switching. Now the next one is the optical data storage. Okay, so here the data is being stored in the optically readable medium. Okay, so data is recorded by making the marks in a pattern that can be read back with the help of a beam of laser light which is focused on a spinning optical disc. Okay, this is something which you have seen in case of your CD drive or DVD drive, okay, or CD player, DVD player. So here the microform is an older example of the optical data storage that does not require the use of a computer, and there are different methods of optical data storing. And an optical disk drive is a device in a computer that can read the CD-ROMs. Okay, so CD-ROMs or other optical discs such as your DVDs or Blu-ray disc can be used in the computer. Okay, now optical data storage actually differs from other storage devices such as magnetic data storage, and here this optical data storage can range from a single drive reading a single CD-ROM to multiple drives reading multiple disks such as an optical junk box. Okay, now a single compact disc, that is in short CD, okay, CD means compact disc, can store around 700 MB, means 700 megabyte data, and the optical junk box can store much more data. Now single layer DVD, if we see, it can store 4.7 GB data or 4.7 gigabyte data. but the dual layer DVD can store 8.5 GB data. Okay, similarly, the double sided DVD with readable surfaces on both the sides of the disk can store around 9.4 to 17 GB of data. Similarly, the HD, that is high definition DVD, can store up to 15 GB data with a single layer and 30 GB data with a dual layer or double layer. Then your Blu-ray disc can store 25 GB data with a single layer and 50 GB data with a dual layer. Okay, so nanomaterials can be used for the development of disruptive methods for optical data storage with ultra high capacity, ultra long lifetime, and ultra low energy consumption, because they have unique mechanical, electronic, and optical properties causing the strong confinement of electrons, photons, and phonons at the nanoscale. Okay, now let us see how this data is being memorized optically. Okay, so optical memory is the latest mass memory technology which has a promising future, and the operation of an optical memory is based on the reflection or scattering of an extremely narrow laser beam of a disk that has microscopic pits or bubbles which are representing the logic which is burned on its surface. And optical memories are of generally three types, namely compact disc, that is CD, then digital versatile disc, that is DVD, and Blu-ray disc. Okay, so first one is the compact disc, which is CD. So it is an optical storage device having a storage capacity up to 700 MB or megabyte, and it is relatively cheaper. Okay, and again it is classified into three types, namely CD-ROM, that is compact disc read only memory. Okay, then CDR, that is compact disc recordable, where you can write the data only once and after that you cannot erase. And the finally we have CDRW, that is compact disc read or write. Okay, so you can rewrite whenever you want to write, or you can erase the data. Okay, so first one is the CD-ROM. Okay, so CD-ROM devices are mass produced in factory. That means these are produced in a very large quantity by using a stamp press technology. Now these CD-ROM drives use the laser technology in order to read the data from it. For this purpose, a semiconductor laser will generate a high intensity light wave of stable wavelength around 780 millimeter. Thereafter, a lens system will direct this laser beam towards the disk over 1 micrometer diameter spot. Then the intensity of the reflected light from the metallic reflection layer will be received by the photosensor, which will give you the information of the binary data which is stored in the CD. So remember, in the CD the data is being stored in binary form. Okay, now there are two different surfaces which are called pit and land from which the reflection occurs. Okay, the pit is 0.12 micrometer deep as compared to the land, and reflected intensities are about 25% and 70% from the pit and land respectively. Okay, the intensity of the reflected light will be changed every time when the laser beam travels from the land to pit or pit to land, and this change is read as your binary 1, and the constant intensity of reflected light is interpreted as 0, that is the binary 0. Okay, the pit width is such that there is at least 2 and at most 10 zeros between every binary 1. Okay, and this is done by converting every 8 bit byte into 14 bit value by a process which is called as your 8 to 14 modulation, in short EFM. Okay, the diameter of a CD-ROM is about 12 centimeter and its depth is 1.2 millimeter. Similarly, the depth of a CD-ROM has four parts, namely the label layer, protective layer, reflective layer, and transparent substrate layer. Now the pits and lands are formed on these transparent substrate layer, and this CD-ROM is actually highly reliable because here the data is being protected by 10 to 20 micrometer thick protective Lec-5 layer on one side and label on the other side of 1.2 millimeter thick polycarbonate layer. Okay, hence the data can be maintained for years without any loss in the normal physical abuses. And suppose accidentally, if small scratches are done on the surfaces, then also it will not directly erase the data but will create extra areas for light scattering. Okay, so here the data is stored in form of a spiral of around 20,000 windings and totaling up to 4.5 kilometer of length, and it contains 2 billion shallow pits on the surface. Okay, and the symbol of the CD-ROM will represent the speed at which the data is being read from the CD-ROM. Okay, and the symbol, suppose 1x or 1 cross, will stand for 150 kbps, that is 150 kilobyte per second. Okay, so commercially the CD-ROMs which are available today are having speed range of 45 cross to 75 cross. For example, the speed of a CD-ROM has four parts, namely the label layer, protective layer, reflective layer, and transparent substrate layer. Now the pits and lands are formed on these transparent substrate layer, and this CD-ROM is actually highly reliable because here the data is being protected by 10 to 20 micrometer thick protective Lec-5 layer on one side and label on the other side of 1.2 millimeter thick polycarbonate layer. Okay, hence the data can be maintained for years without any loss in the normal physical abuses. And suppose accidentally, if small scratches are done on the surfaces, then also it will not directly erase the data but will create extra areas for light scattering. Okay, so here the data is stored in form of a spiral of around 20,000 windings and totaling up to 4.5 kilometer of length, and it contains 2 billion shallow pits on the surface. Okay, and the symbol of the CD-ROM will represent the speed at which the data is being read from the CD-ROM. Okay, and the symbol, suppose 1x or 1 cross, will stand for 150 kbps, that is 150 kilobyte per second. Okay, so commercially, the CD-ROMs which are available today are having speed range of 48 cross to 75 cross. For example, the speed of a 48 cross CD-ROM will be 48 into 150 kbps, that is 7200, that is 7200 kbps. Similarly, 75 cross CD will have 75 into 150 kbps, that is 11,250 kbps. Okay, then the next one is the CDR or compact disc recordable, which is allowing to write the data only once and thereafter it cannot be erased. Okay, so here the CDR drive has laser unit which uses the higher intensity light wave for writing the operation than that for your reading operation. Okay, now CDR disk does not have pits and lands, but it has a photosensitive organic dye between the reflective layer and polycarbonate substrate that write the laser, which heats nearly to 250 degrees Celsius. Okay, and this melts the dye to form a depression mark in the recording layer in a proper places. Okay, and the places which are burnt have lower reflectivity of light. Hence, the read laser has two different intensities on reflected light while reading the disk. Okay, earlier version of this CDR was called as your worm. Okay, worm means write once, read many times. Okay, and this worm requires data to be written in only one session or one go. Now the CDR can be written in multiple sessions till it is completely filled. Okay, and the writing speed of this CDR is quite slow than the reading speed. Okay, thereafter the next one is the CDRW, that is the compact disk rewritable or CD read write, which is an erasable disk in which the data can be written and also erased how many times you want. Okay, so CDRW uses an active layer of silver indium antimony tellurium alloy. Okay, and it has a polycrystalline structure making it reflective. And here the writing data on the CDRW uses highest power of laser which heats the selected places up to 500 to 700 degrees Celsius. So at this high temperature the chemical structure liquefies, lodging its polycrystalline structure, and cooling solidifies to an amorphous state whose reflectivity is being reduced from 25 to 15%. Okay, so the read operation in case of this CDRW is similar to that of your CD-ROM and CDR, that notes the difference in the reflectivity on the reflecting surfaces. Now to erase the data, the laser is being operated at a lower power setting and it heats the active material to around 200 degrees Celsius. So this converts the material from amorphous state to again its polycrystalline structure and will make the material reflective again. Okay, so in a CDRW the rewrite operation can be done over 1000 times or more. Okay, suppose for example in a CDRW it is written that 12 cross oblique 10 cross oblique 32 cross. So it indicates that the CPU, that is the central processing unit, and the media which is permitting the CD drive can write the CDR disk at a 12 cross speed. Okay, then it can write to CDRW disk at a 10 cross speed. Okay, and read from the CD at a speed of 32 cross. Okay, now the next one is the DVD, that is the digital versatile disc. Okay, so it is also known as the digital video disc, and it is an optical storage device that looks like a compact disc. Okay, and the DVD is able to store nearly 15 times more data than the storage capacity of a CD, and it can transfer the data to a computer about 20 times faster than that of a CD-ROM. Okay, now this DVD is also known as the super density disk, in short SD, and it can store the data up to 17 gigabytes, that is 17 GB, and it can also store 4 hours of movies on one side. Okay, the DVD drives use smaller wavelength, which is 635 to 650 millimeter, and lower numerical aperture lens system in order to read the smaller dimension of land and pits. Okay, now each side will have two layers from which the data is being read, and in certain disk data is written on both the sides of the DVD. Okay, now single sided single layer DVD will have a storage capacity of 4.7 GB. Similarly, single sided double layer DVD has a capacity of 8.5 GB. Double sided single layer DVD having a capacity of storage that is 9.4 GB, but double layer DVD has a storage capacity of 17.1 GB. Okay, now in DVD terminology, 1x, that is 1 cross, means 1.32 Mbps. Okay, that means 1.32 megabyte per second, and there are again three types of DVDs, namely the DVD-ROM, DVD-R, and DVD-RW. Okay, which is similar to that of your CD. So first one is the DVD-ROM. So it is the digital video disc read only memory. and it is an optical storage device having storage capacity between 4.7 to 17.1 GB. And these DVD ROMs are actually originally developed for the movie industry. Okay, so you can store the movie in the DVD, and huge capacity of storage will make them attractive for the storage purpose of large amounts of data. Okay, the DVD ROMs drive can read the audio CDs, CD-ROMs, CDRs, and CDRWs. Okay, the next one is the DVD-R, which is the digital video disc recordable. So it allows to write the data on the disc only one time, and thereafter you can read it many times as you want, but the data cannot be erased. Okay, then the next one is the DVD RW, which is the digital video disc rewritable or DVD read write, and it is an erasable disk. Okay, so you can erase the data whenever you want to. Okay, so here the data can be written and erased as many times as you want. Okay, so this is all about the DVD. Then finally, the Blu-ray disc, in short BD. Actually, it is an optical storage disk format which is having the same dimension as that of the standard DVD or CD. But the BD is used for high definition, that is HD video and data storage. Okay, so the BD format uses a blue violet laser instead of red laser. That is why it is called Blu-ray disc. Okay, so the new BD format can store 5 times more data than the DVD capacity. So here the storage capacity of this BD is up to 25 GB on a single layer disk and 50 GB on a double layer disk. And BD is used for recording, rewriting, playback of HD video and storing large amounts of data. Okay, the advantages of using this blue violet laser, which is having a wavelength of 405 nanometer, is that it has a short wavelength and it is shorter as compared to the red laser light, which is having a wavelength of 650 nanometer. So it makes possible to focus the blue violet laser with even greater precision. Okay, so this allows the data to be packed more tightly and stored in less space. Okay, so the more data will be stored in less space. Okay, so it will be increasing the efficiency. Okay, so therefore it is possible to fit more and more data on the Blu-ray disc. Okay, so this is all about the optical switching and optical data storage, which I have taken from one book. Again, I advise you to read the same thing which I have taken from another book, but here it is given in a very brief format and point wise. Okay, so in the optical switching, where we have already read about the optomechanical, electro optic and thermal switching, so besides those it has given also about the MEMS, that is the micro electromechanical system devices. This we will study in detail in the upcoming classes. For the time being, in brief, the MEMS devices use teeny reflective surfaces in order to redirect the light beams to a desired port by either ricocheting the light of the neighboring reflective surfaces to a port. Okay, so here the word ricocheting means it is similar to that of rebound. Okay, like that of in case of a football, where the penalty kick, the rebound, the player has a chance, a second chance to kick the football again towards the goal post. Okay, so similarly the light, when it is being incident on a surface, it is going back, and on a rebound or ricocheting process it is going to another place of that same surface. Okay, so this is one method. Now the second method you can do by steering the light beam directly to a port. So the MEMS based switching approaches are as follows. Number one, the 2D, that is two dimensional or digital, in which the switches are digital as the mirror position is bistable. Then number two, the 3D or analog, in which the mirrors operate in the analog, that is continuous mode. Okay, so the MEMS technology facilitates the fabrication of actuated mechanical structures with fine precision which cannot be seen through naked eye. Okay, and the MEMS devices are compact and consume low power. In addition to that, they have high volume production which is possible, and hence the cost will be very much less. Okay, now the optical storage, where we have already read about the pits and lands, where it has given a very simplified definition. The flat areas will be called as lands, which represent the ones of the binary, and the bumpy areas are called pits, which will represent the zeros of the binary on the surface of the disks. Okay, then the optical storage data has the following advantages, which are given here point wise. Okay, you can read it. Like the mass storage capacity will range into some gigabytes, where 1 gigabyte is equal to 10 to the power 9 bytes. Okay, then it will have low cost per bit of storage, then longer life of optical data storage in media, then higher data stability, then mountable or unmountable storage units, then lesser area per bit storage, which is required on optical platter, that is disk, as compared to the conventional magnetic disks. Okay, then it has given about the classification, where the CD, then DVD, then Blu-ray disk, which we have already studied. Then finally it has given about the advantages of optical storage devices along with the disadvantages or drawbacks. So in advantages, it will be non-volatile, that is the memory is retained even when the power is off. Then durability, that is the optical media can last for a longer time. Then optical storage devices are removable. Then transportability, here the data which is written on a DVD RAM can be read on a PC or computer or any other system. Okay, then it is great for archiving, because when the written data is for only once, then they cannot be reused. Okay, you cannot erase that, so data is permanently being preserved or archived, right? Then random access, that is the data can be randomly accessed without following any particular sequence or procedure. So this means access time is low and hence higher operating speed. Okay, but it has also some of the drawbacks or disadvantages, like worm. The worm disks are permanent, so the data cannot be altered or changed at a later stage after fabrication, hence they are not user friendly. Then the optical discs require special drives to read or write, and lesser storage capacity is there at comparison to the other storage technology. And finally, the optical storage rewritable formats will suffer from compatibility issues between the drives. Okay, so finally I advise you to go through the PDF completely. Okay, read from both the books that I have included and make your note accordingly. Okay.
Thank you.